Good afternoon, everyone. I'm Li Xiangyu from China Mobile Cloud. I'm the China Mobile Cloud General Computing Product Team Leader, and I'm also the Open Infra Foundation Gold Director and the Open Infra Asia Advanced Learning Committee member. Today, I will introduce China Mobile's intelligent resource and scheduling in China Mobile Cloud. So this topic has three parts. So I will introduce some backgrounds. With the continuous development of AI and large model, the growth rate of computing power demands has far exceeds Moore's law. The rapid growth of data has led to a surge in demand for AI computing power. By 2030, the demand for AI computing power is expected to increase by nearly 390x. So the technology we use for resource management and scheduling really needs to be high performance, scalable, and efficient. First of all, let me give you a quick rundown of China Mobile Cloud. China Mobile Cloud is intelligent, secure, and performance, and it is designed to give users the best possible experience. We've got an edge when it comes to resource with our 4N31X layout, meaning we've got bases all over the place in China. We're talking full coverage in resource-rich province, and we've been the fastest development in the industry for the past 3 years. China Mobile Cloud has a lot going for it, especially its technical capability. We've got over 230 original products. China Mobile Cloud now has a pretty cool setup. It's split into three main parts: a standard infrastructure layer, a smart resource scheduling layer, and a worldwide business orchestration layer. At this infrastructure layer, we have developed Panshi brand server and Panshi ASIC DPU chip. At the same time, we have upgraded the Coca computing architecture, fully release hardware capability through software and hardware integration. The end-to-end network collaboration enables the interconnecting of over 10,000 cars, intelligent computing clusters, achieving seamless cross-architecture integration of AI chips. The data and AI driven are the two key features of the resource scheduling layer. The big cloud 本源 The big cloud 本源 elastic computing system adopts an industry-leading one single layer domain architecture. A single AZ supports 100,000 computing nodes, and a single region supports 3 or more AZs. When an elastic computing system achieves the delivery of 5,000 visual machines in 10 minutes under 5,000 concurrent scenarios. The global business orchestration layer can also be called the computing network brain. The orchestration and scheduling performance has reached 10 million levels a day. feature in this meeting is a key technology used in Hunyuan elastic computing system. In the development journey of China Mobile Cloud's Hunyuan elastic compute system before 2018, it based on OpenStack architecture. Management scale reaches over 1,000 hosts per AZ. In 2019, Hunyuan released technology architecture version 1 for large-scale scenarios, supports multi-cell architecture. Management scale increased over 5,000 hosts per AZ, and developed a new scheduler for large-scale scenarios. Has a 95% improvement in scheduling performance before all architecture. And from 2021 to 23, Hunyuan architecture version 2 for complex scenarios released. The management scale ability increased to 100,000 hosts per AZ. The new scheduler introduced custom tasks, priority, availability, low scheduling capability, and so on. It supports AZ-list, region-list schedule, and cross-AZ, cross-domain disaster recovery capability, and second-level fraud recovery. For the cloud computing providers, building a computing resource management system that embraces high performance, stability, and efficiency is a core strategy to drive continuous business growth, enhance the corporate competitiveness. China Mobile Cloud can handle instance demands ranging from hundreds to thousands within seconds to minutes. The resource allocation speed reaches millions per day. Currently, China Mobile Cloud service customers has reached 2 million. Behind the rapid growth in the revenue and the users in China Mobile Cloud, readiness appreciation of cloud computing technology and service quality. We pursue an ultimate technology continuous optimize and restructure the system and enhance the capability. Now I will introduce China Mobile Cloud Schedule Architecture. It consists of four parts: Stability Intelligence Center, Inventory System, Online Scheduler, and Offline Scheduler, which are responsible for the data and the algorithm platform. Capacity management, efficient resource allocation, and enhancement of resource benefits, respectively. The inventory system is a managed system to reserve resource and try to make use of ideal resource. Stability in the middle. The Stability Intelligence Center in the middle contains a data center and intelligent models. It is the base for the intelligent schedules system. Offline scheduler. Offline scheduler adjusts layout by migrating resource and gives online scheduler guidance. Online schedule system allocate resource in the list time and measure resource for AZ list and region list. This page highlights the remarkable advantage of the paging scheduler system. Significantly enhance schedule performance by leveraging a array and paging a scheduling mechanism. The system maintains stable scheduling times as it scales up, avoiding the decline in performance in traditional system. Under actual testing at a 5,000 nodes scale, The system achieved over 90% improvements in scheduling efficiency. The key implementations, such as the strategy patching, efficient filters, weight calculation, and a page mechanism, contribute to this boost. Strategy tracing preload data on the host flow and task, minimize database queries during scheduling. Efficient filter minimize the unnecessary database interruptions while resource waste are calculated during load reporting. Optimizing computational efficiency. The paging mechanism reduces computational load and loss based on wave leads. Additional DB application minimize error writes and database queries. Better enhance systems performance. This page showcases the core architecture and functionality of the multi-features schedule system, integrating strategy weighting, resource weighting, and intelligent scheduling algorithms by employing a feature tagging system. This system achieves highly flexible scheduling across various features and scenarios, including the location, server affinity, tenants differentiations, and more. This significantly enhances the adaptability and versatility of the schedule system. Furthermore, the system supports amplified allocation and scheduling of both general-purpose computing power and various heterogeneous computing resources, such as GPU and GPU, catering to deliver a diverse user computing needs through a combination of a custom tag system, cost-aggregated system, and diverse scheduling algorithms. The system ensures different scheduling for multiple scenarios and resource types, enhance users' performance, stability, and satisfy multi-scenarios ordering requirements, and boosting product sales. With the continuous operation of the cloud computing service, the fragmentation rate of the resource pools is gradually increasing, making it increasingly difficult to meet the resource capability requires to create large flavor visual machines. To solve this problem, China Mobile has adopted the following methods. First, one-time scheduling recommendation based on a comprehensive evaluation model. We reducing the rate of resource pool fragmentation as the main evaluation method. Multi-dimensional cloud host recommendations, visual machine recommendations are made for one-time scheduling to influence the threat of one-time scheduling and ensure the number of large flavor visual machines that can be created. The second is the secondary scheduling rehearsal based on the computing power view of visual machine purchase, host purchase, and time series data statistical analysis is conducted to ensure the creation quality of large flavor visual machines as the main goal, and some necessary constraints are introduced. Then, based on the intelligent optimization algorithms, the optimal migration route is calculated and executed through task follow orchestration, thereby reduce resource fragmentation rate and increasing the number of large flavor visual machines that can be created. And we also have created a specification granularity resource reservation mechanism, which avoids whole machine locking during resource reservation, reduce the scope of resource reservation, lowers the cost of resource reservation by scheduling users' time reserved for resource. The determinacy of the customer's resource is ensured and the user experience is improved. We also provide users with the intelligent resource recommendation based on the user data, resource capability, the region's codes, and other information, combined with the global balance scheduling capability of the computing network grid. This improve the user's ordering experiment and achieve the goal of the regional resource balance. We have also involved the mechanism of prioritizing the utilization of the ideal resource by allocating the ideal resource to the task-based service through the brain of the computing network, realizing the value of the idle resources and reducing the cost of the reserved resource. To solve the problems such as the high cost of the GPU resource, low utilization rates in the central resource pools, the inflexible resource allocation, China Mobile Cloud has independently developed GPU pooling technology with the following key features. The first one is the heterogeneous computing pool management. By utilizing GPU pooling technology, GPU and CPU resources are decoupled, allowing resources to flow flexibly within the cluster while making hardware difference. This technology provides unified management and scheduling capability for the heterogeneous computing, significantly improve resource utilization and efficiency. The second key technology is the fine-grained heterogeneous computing allocation. Leverage utilization technology with hardware-software collaboration. The software can flexible define the number of visual machines. The approach supports seamless scales of computing resource and integrates both spatial and temporal mechanics, increasing the utilization of the resource by up to threefold and optimizing the fine-grained resource allocation. The third key technology is the flexible computing resource allocation. With the cloud-native API integration, users do not need to be aware of the underlying resources. Instead, they can define resources usage based on their actual business needs. The last key technology is the remote GPU access. The platform offers remote access to the GPU resources, enabling the fulfillment of the compute needs across different locations of devices, ensuring flexibility and accessibility in the resource usage. This page introduces the kernel-level features that enable mixed deployment of high and low priority visual machines within a single compute node. Ensure resource allocation priorities and stabilities based on the open-envelope kernel feature. The system differentiates CPU resource allocation for virtual machines of very priorities in the scenarios where high priority virtual machines compete with the low priority virtual machines for the CPU resource. The system priorities the former and ensure their quality of the service. When the high priority virtual machines are idle, the system allocates the idle CPU resources to the low priority virtual machines, effectively enhance the CPU utilization during maintaining the performance stabilities of the enterprise-grade virtual machines. In the means deployment scenarios, the priority of the virtual machine CPU and RAM is ensured by the kernel feature provided by the kernel. Storage resource isolation is granted by the whole machine disk I/O controller, while the network resource isolation is ensured by the whole machine network speed controller. This prevents the decline in stability caused by the resource contention among the different virtual machines. On this page, I will introduce how we continuously improve the stability of all our computing resources through secondary scheduling. Firstly, based on massive computing power observation data, we have introduced real-time computing technology to quickly analyze and observation data. While the perception model detects abnormal computing resources, it will generate optimization strategies based on present scenario-based optimization algorithms. Finally, during the execution of optimization actions, we utilize the multi-objective optimization algorithms to generate migration paths and optimize the duration of abnormal resource through leaf migration. This page introduces the disaster recovery and migration mechanism in China Mobile Cloud. We developed the cross AZ and full system disaster recovery capability for the virtual machine, implementing the crash consist snapshot glue technology and cross AZ data replication at the storage layer. This capability ensure the safety and protection of the critical business data across AZs. In additionally, literally, object storage cross-region replication technology to enable inter-wrapper migration capability of image and backup resource across the entire network data plane. And the second one is the cloud migration. Overcome the limitations imposed by the existing cloud computing platform architecture on the availability zones, enabling smooth migration of virtual machines between AZs while ensuring the business continuity. The last chapter I will introduce what the China Mobile Cloud is doing and will do in resource management and scheduling. In the future, in order to optimize the existing scheduling algorithms and effective accurate the flexibility of newly introduced algorithms, I believe we need to scheduling simulators to evaluate the effectiveness of the algorithm from multiple dimensions in order to make better choices through horizontal comparisons. We can also track AI scheduling algorithms based on the input and output data of the scheduling simulator, efficiently improve the goal optimization capability of a single scheduling. Meanwhile, the state of the resource pool and the distribution of visual machines are dynamically changing. The scheduling scenarios are gradually change over the time. When the scheduling scenario changes, it is necessary to adjust the scheduling strategy in a timely manner to ensure that the resource pool state and visual machine distribution are optimized in a reasonable direction. Therefore, we need the ability to recognize dynamic scenarios and generate different scheduling strategies based on the different scenarios in order to dynamically adjust the optimization direction of the resource pool. Okay, this is all of the topic. Welcome to go to this website to know more about the China Mobile. Thank you.